Hi, good evening. Am I audible? Is there any question you may ask? If there is any question related to last lecture, then you may ask. Meanwhile, other participants will be joining. I guess there is no question from any one of you, and now I should start our next topic. In the last lecture, we did the practice questions of activity-based costing from the practice kit, as well as we covered target costing. Do you remember that what we have covered in the last lecture? Okay, so I'm sharing the screen. I hope screen is also visible to you now. So let's start our today's topic, and the today's topic is life cycle costing. So first of all, let's start our today's topic. Then I will move you to the practice kit of target costing as well as life cycle costing. Life cycle costing is very simple and very easy topic. So first of all, let's understand the meaning of life cycle costing. As we all know that we are doing the costing techniques, and this is our third costing techniques, which is known as life cycle costing. Life cycle costing is basically costing is a technique used to calculate life cycle cost of a product. Now we need to understand that what is a life cycle. As far as life cycle is concerned, let me draw a picture that this is a time frame, and product life cycle goes like this one. This stage is basically the research and development stage, under which the product is not launched to the market, and research and development is being done on this product for which we are going to launch. So research and development is basically the first stage of the product, which is the idea is that for a new idea, we do some research and then we develop the product, and then ultimately we launch the product into the market. So ultimately we launch a product into the market, and then this stage is introduction stage, that the product is launched in the market. So this is the introduction phase. Then ultimately the sales grow up. So this is a growth stage, and where the sales are maximum, this is known as maturity stage. And after maturity, there is again a decline. And in some cases, if we add some new features in a product, we can again go to the higher side of the life cycle. But mostly nowadays, as we know that the products are changes rapidly with the change in technology. So we will be discussing the 5 stages of the product life cycle. First one is research and development. Second is introduction stage. Third one is growth stage, then maturity, and the fifth one is the declining stage of a product. So basically, what we learned that every product goes through the 5 stages of the life cycle. So as an accountant, what we need to do, what our examiner is expecting from us from this topic. So first of all, examiner will be can ask you, the examiner can ask you about the questions related to the concepts of basic concepts of the life cycle cost and the life cycle costing. So overall life cycle consists of 5 stages, and under the life cycle costing, we need to find the life cycle cost. Life cycle cost per unit. So basically, we will calculate the total life cycle cost, that how much money is spent in research and development, how many funds are being paid, then how much cost is being paid or incurred at introduction stage of the product life cycle, then how many expenses or costs are incurred at growth stage, then how many dollars are incurred on maturity stage, then how many dollars are incurred in declining stage. So this is the whole life cycle cost. And then we will get the number of units. We will divide with the number of units in a life cycle. Then we will get the per unit cost of the whole life cycle. So the life cycle cost per unit is basically calculated. First of all, we calculate the total life cycle cost. The life cycle duration could be 1 year, 3 year, 5 year, or whatever. So basically, there are 5 stages. The 5 stages of a product can be covered in 1 year, 3 years, or 5 years, depending upon the time duration of the product life cycle. Is it clear? Please confirm if there is any confusion or any question from your side. Is it clear? So this was the whole idea of the product life cycle, and we will be doing this with the help of handouts as well. So this is the life cycle costing. And there is a brief introduction of the stages. And the product life cycle can be divided into 5 phases: development, introduction, growth, maturity, and decline. Every product goes through a life cycle. And what is the development stage? What is the introduction stage? What is the growth stage, maturity, and decline? And if you look at this picture, there are two curves. One is related to profit, and other one is related to revenue. If you look at the phases, that in a research and development phase and the introduction phase, mostly there are losses. So these areas are below the zero line. So these are showing the losses. And after the growth phase, there is a profit. And if you look at this, the height here is at the maximum. So this is the maturity level. And similarly, the sales at the maturity level are at a maximum level. So whenever the time goes on, the maturity level is achieved, and after maturity, after some time, maybe some months or even a year, there must be a decline in the product's demand because some superior product will uh, be available for the customers. So this is a graph showing the sales revenue and the profit of a product among different life phases of the product. What are the benefits of life cycle costing? There are a number of benefits associated with the life cycle costing. The life cycle concept results in earlier action to generate revenue to the lower cost than otherwise might be considered. Better decisions should follow from a more accurate and realistic assessment of the revenues and cost, at least within a particular life cycle stage. Life cycle thinking can promote long-term rewarding in the contrast to the short-term profitability rewarding. What is the meaning of the third benefit? The meaning of the third benefit is that the life cycle costing is more focusing on the longer term results, because if there is a loss in the 1 year, the management will not be of the opinion that to shut down this product, because we are having the cost of the whole life cycle. So life cycle is more promoting the longer term view of a product. The life cycle concept helps the managers to understand the acquisition cost versus operating cost and support cost. It encourages the businesses to find a correct balance between investment cost and the operating expenses. Life cycle costing in manufacturing and service industries can similarly, we have discussed the same point whether the target costing can be applied to the manufacturing and services. So today we are going to discuss the life cycle costing in the manufacturing and the service industry. Both manufacturing and service industries take similar steps to ensure that the returns are maximized over the product or service life cycle. So there might be a service life cycle as well. With the life cycle costing, non-production costs are traced to the individual products over the complete life cycle. So we are not only focusing on the production cost, we are also focusing on the non-production cost, for example, selling, administration. The total of these costs for each individual products can therefore be reported and compared with the revenues generated in future. So ultimately, we will get the whole life cycle profit if we compare the cost with the revenues. The visibility of such cost is increased. Individual product profitability can be better understood by attributing all costs to the products. As a consequence, more accurate feedback information is available on the organization's success or failure in developing the new product. In today's competitive environment, where the ability to produce new or updated version of the product is paramount to the survival of the organization, this information is a vital. So this is all about the theoretical area. Now we will move to the practice question, that in which way the examiner will be asking you. First of all, this area will be tested in MCQs, but I will do one or two comprehensive questions so that you people can understand the basic idea of the calculation in a longer point of view. So I'm reading example number 1. Solaris specializes in the manufacture of the solar panels. It is planning to introduce a new slim line solar panels, especially designed for small houses. Development of the new panel is to begin shortly, and Solaris is in the process of determining the price of the panel. It expects the new product have the following cost. So units manufactured are given. It means the life is consisted into 4 years, 1, 2, 3, and 4. Number of units manufactured and sold are given. Then there are research and development costs incurred in year 1 and year 2. Marketing costs are incurred in year 1, 2, 3, and 4. If you look at the cost, the marketing at the earlier year is more. Then gradually the marketing is reduced. Why? Normally the in the first year, they are putting more investment on the marketing, because in the life cycle costing, we assume that the product is of a life cycle and we need to tell people. So that's why companies are more investing in marketing in the early stages of the product life cycle. Then there is a production cost per unit given, that how much money the company will be incurring to produce a 1 unit of the product. Then there is a customer services cost, and then there is a disposal cost associated with the equipment. The marketing director believes that the customer will be prepared to pay $500 for a solar panel. So this is the proposed price by a marketing director. But the financial director believes this will not cover all the costs throughout the life cycle. So finance director is of the view that this price is not sufficient to recover the whole life cycle cost. And what is the requirement? Calculate the cost per unit, looking at the whole life cycle, and comment on the suggested price. So first of all, we need to find the total life cycle cost per unit, and what will be the format. We will be doing the calculation year wise. Year 1, 2, 3, 4, and we can also do the total of each line item. So the first cost is research and development. How many dollars have been spent on research and development? 1.9 million and 100,000. So I will round the whole calculations in thousand. So I will write it as 1900 and this as 100, and the total will be 2 million. So year wise figures are given and I made a total, and no research and development have been incurred in year 3 and 4. Then there is a marketing cost. So the second line item is the marketing cost. In the first year, it is 100. In the second year, 75,000. In the third year, 50 and 10. So what will be the total of this? The total of the marketing cost. Then production cost per unit is given. So 235,000 is the total of the marketing cost. And now production cost. This is per unit 500. And how many units are being produced in year 1? 2000. So we will multiply it 500 with the 2000. So it will be how much? 1 million, I guess. Okay. And in the second, 15,000 into 450. So what will be the total? 15 into 450. 1,000 will be rounded. 6750. Okay. So this is 6.75 million. And in the third year, 20,000 into 400. So this will be 20 into 400. 8 million. Okay. And in the fourth year, 5,000 into 450. 5 into 450. So 2250. And what will be the total of these production cost? Make a total. So 18,000. And is there any cost? Yes, there is another cost, customer services cost per unit. So we will convert it into total customer services cost. The per unit cost is given 50. So 50 into 2 will be 100 for year 1. 40 into 15. So this will be 60. 40 into 20. 20 into 40. 800. Then 40 into 5. This will be 200. So 1700 is the total of customer services cost. Then there is another cost, disposal cost, and disposal cost is given in total, and it is only in the last year 300,000. So there is disposal cost. So what is the total life cycle cost? Total life cycle cost. Please make a total of this column. We can also have a total year wise, but no need to find the year wise total. Our main concept is to calculate the total life cycle cost of a product. So this is 22235. And what is the formula for the life cycle cost per unit? Life cycle cost per unit is equal to total life cycle cost divided by number of units in the life cycle. Total life cycle cost is 22235,000. And how many units are produced? 20 plus 20, 40, 42,000. So the total units that this company produced in the whole life cycle is 42,000. So what will be the life cycle cost per unit? So 529.41. What was the requirement? The requirement was calculate the cost, life cycle cost per unit. And so calculation is done and comment on the suggested price. So what comment we should write? We will write the cost per unit of the whole life cycle of the solar panel is $529.41, which is lower than the suggested price by the marketing director by $29.41. So if we are selling the solar panel at a suggested price of the marketing director, then we will be bearing a loss. So 520, the solar panels must not be sold below 529.41. Please let me know if there is any confusion in the calculation or any confusion in the comment. Is it clear? The whole question is solved in front of you. If there is any question, I'm waiting. Is there any question or should I move forward? Okay, so that was a long question in these handouts. Now we will move to the practice kit. And in the practice kit, the first topic that we will be doing is related to target costing. So can you please answer the question of target costing, question number 42? In a target costing, which of the following would be an appropriate strategy to reduce the cost gap for a product that existed in a competitive industry with a demanding shareholders? So, what should be a step to reduce the target cost gap? I'm waiting for your answer. And if you will not be able to answer, then let me know. I will tell you. This is very easy question. Question number 42 is very easy. We all know that we cannot increase the price or we cannot reduce the margin. So the first 3 points are related to this concept. So these are not relevant. The D option is relevant. No, we cannot change price or the desired margin to reduce the gap. We can only do something which will result in the lower of the average production cost. So the right answer is the D. Because let me remind you that in a target cost gap, we have only studied for those points which will result in the lower of cost. For example, search for the alternate labor, search for the alternate design, search for the alternate material. So all these factors are related to the reduction in the cost per unit. None of these points that we have studied in the last class was related to the reduction in price or reduction in profit margins. So A, B, C are not relevant. Is it clear? So move to the next question. Which of the following strategies would be an immediate acceptable method to reduce an identified gap? So you can try it. I'm waiting. Which option should be the answer for question number 43? This is also a very easy question. Yes, C is the right answer. Okay, question number 44 is related to the calculation. The predicted selling price of a product is 56. The desired markup on cost is 25%. Now this is markup and the material cost of the product is estimated to be $16 before allowing any additional material to allow for shrinkage of 20%. And what is the meaning of shrinkage? Shrinkage is basically a loss. For every 10 kgs of material going in, only 8 kgs come out. So there is a 2 kg loss. If the labor is only the other cost and the 2 hours are needed, what is the most business can pay per hour if there is a cost gap is to be avoided? So This is basically the reverse calculation. First of all, we need to have the target cost gap. Target cost gap is equal to estimated cost minus target cost. So we need to have these two figures. Target cost, we know the formula. Sale price minus profit, desired profit. The sale price is given in the question, $56 per unit. So this is 56. And the profit is given as a markup, 25% on cost. So the cost is not available. So I assume that the target cost is equal to C. So this will be 0.25 C. How 0.25 C? Because it is 25% of cost. So 25% will be 0.25. So this will be C plus 0.25 C will be equal to 56. So this will be 1.25 C is equal to 56. So what will be the cost? 56 over 1.25. So what is the target cost? So this is 44.8. So here this is 44.8. Now, in the question, it was written that the company wants to avoid any cost gap. To avoid the cost gap means that the cost gap is equal to 0. It means this is equal to 0. So what is our estimated cost? Estimated cost is also equal to 44.8. So we will solve it and we will get the estimated cost. Previously, we normally calculate the estimated cost by adding material, labor, and other costs. But now it was given in the question that there will be no cost gap. So the cost gap will be 0. So the estimated cost will be equal to target cost. Now we will estimate that how much dollar will be spent for direct materials, how many dollars will be spent for direct labor, and how many dollars will be spent for the other cost, and then this will be equal to estimated cost. So the estimated cost we are already having 44.8. Now how much material cost will be incurred? $16. And it was written that before allowing for any additional material for the shrinkage. So we need to adjust this cost because $16 is showing the 80%. Why 80%? Because there is a 20% loss. So ultimately the cost will be increased. So what will be the 100% cost? As it was given in the question that there is 16% is before allowing for any shrinkage. And this is $16 not per kg. So this was the total material cost of this product, but this is only before allowing for any loss. So there is a 20% loss. Ultimately, the cost is showing 80%. So 16 over 80%, 16 over 0.8. How much will be the original material cost? Students, please participate. And if there is any confusion, everyone should try to clear that confusion. You can freely ask me if you are not getting any idea or any calculation. So this is 28.8. I guess this is too much. You can just recheck it. 16 over 0.8. Yes, 20 seems to be good. So this is 20. And what is next in the question? And there is the labor hours required 2. Okay. So for labor, we have 2 hours and the rate per hour is missing. And there is no other cost. It means the remainder, the balancing figure will be 24.8. Why 24.8? Because it is given that there is no other cost. So there are only two items available for the data. For one is for the direct material and other one is for the direct labor. So then we are sure that the remainder of the cost, the balancing figure 24.8. How we get the 24.8? The difference between total cost and the cost of the material. And how we can get 24.8 if there are 2 hours of labor required. So can you tell me what is the rate per hour? What will be the rate per hour? Because we know that hours into rate will be equal to labor cost. So the rate per hour will be 12.4. So this was required in the question, that how much we are paying to the labor to the two decimal places. So we will write it as 12.40. If you will write 12.4, you will get 0 marks as the instructions are for the two decimal places. So you need to make sure that you are writing two places after the decimal point. So you need to write 12.40. Keep this instruction in your mind because it is written in the requirement. So computer is a dumb and computer will only mark your question correct if there is 12.40. Which of the following technique is not relevant to target costing? The technique which is not relevant to the target costing is variance analysis, value analysis, functional analysis, and activity analysis. These analysis you might have studied in your basic paper of management accounting. So, uh, the value analysis, functional analysis, and activity analysis are the relevant to the target costing, and the variance analysis is not relevant. So the answer of question number 45 is the B option. Now moving to the question number 46, the selling price of a product Sigma is set to be 250 for each unit and the sales for the coming year are expected to be 500 units. The company requires a return of 15% in the coming year on the investment in the product Sigma. What is the target cost of each unit of the Sigma for the coming year? Select the list. Okay. So that for a target cost, we need to have a price. We are given with the price. The price is given 250. And how much desired profit is given? It is given 15% on the investment. So we need to find the return. 250,000 is the investment and we want a return of 15%. So what will be the desired profit for the year? 15% of 250,000. I guess 37,500. Okay. So how many units will be produced in 1 year? 500. So when we will divide it with 500, what will be the profit per unit? Because this is the yearly profit. And how many units we will be producing in the 1 year? 75. So the target cost will be how much? 175. So D option will be the right answer. I hope it is clear. Please let me know if there is any confusion. In this question, there was no markup or margin. It was simply given as a 15% on the total investment, and the investment figure was given in total, and we got the total profit. And why we divided it with the number of units? Because we are going to calculate the per unit target cost. So we need to have a per unit profit figure. Moving to the question number 47. VC company is a firm of opticians. Okay. It provides a range of services to the public, such as eye test and the contact lenses consultation, and has a separate dispensary selling glasses and the contact lenses. A standard appointment is 30 minutes long, during which an optician will assess the patient's specific requirements and provide them with the eye care services they need. After the appointment, patients are offered the chance to buy the contact lenses or the glasses. Which of the following describes the characteristics of the services provided by an optician at the VC during a standard appointment? Is this tangible, homogeneous, non-perishable, or simultaneous? The answer is simultaneous. Why simultaneous? Because the consultant is being offered for a 30 minutes, and during that, as he or she is checking the patient, the time is going on. So our simultaneity means that we are consuming the services as we are receiving it. So this is basically the characteristics identification of the service industry. So the right answer will be the D option. Okay, moving to the next topic, which is our today's topic, life cycle costing. We are given with the following data. Year-wise, expected sales are given, variable cost per unit is given, fixed cost in total, variable selling cost per unit, fixed selling cost, administrative cost. What is the life cycle cost per unit? So this question seems to be the similar copy question that we did already. So let's solve it. How many years are there? 1, 2, 3. So there are 3 years, and we will make a total as well. The first cost is variable cost. So we will convert the variable cost per unit into total. 2.3 into 2000. So what will be the total? 2.3 into 2000. Make a total. 1.8 into 5 and 1.2 into 7. Okay, 4,600 for the first year. $1.8 into 5,000. 9,000. Okay. And what about third year? 1.2 into 7,000. And what will be the total? 22,000. Okay. So there is a fixed cost as well, 3,000, 3,500, and 4,000. 3,000, 3,500, and 4,000. So what will be the total? 10,500. And then variable selling cost. Variable selling cost. It is given on per unit basis, 0.5 into 2000. 0.5 into 2000. So this will be 1,000. Then 0.4 into 5,000. This will be 2000. Then 0.4 into 7,000. This will be 58. Then fixed selling costs are there. The fixed selling costs are 1500, 1600, and 1600. 1500, 16, 16. So the total will be 4700. Then there is another cost, administrative cost, 700 each year. Administrative cost, 700 each year. So this will be 2100. So what will be the total life cycle cost? So what this is 45,100. So this is total life cycle cost and how many units we have produced in the whole life cycle. So this is 2000 plus 5000 plus 7000. So it is 14,000. What will be the life cycle cost per unit? Okay, 3.22. So we will check it whether the option is given. Yes, so C is the right answer, 3.22. I guess the question is clear. Now, for a question number 49, I will not read the question. You people will read it, solve it, and then share your answer. I will give you 5 minutes. So your time starts now. Read the question and read the requirement, understand it and solve it and share the final answer. I'm waiting. Yes, C is the right answer. Very good. I hope the other students have also calculated the same. And if there is any confusion, I'm here to answer that. So there is another question, question number 50, which is also related to the life cycle costing. Which of the following statement made by the chief executive are true regarding the life cycle cost? So you will do it by yourself. The question is easy. There are two statements and you need to select that which statements are true and which statements are false. Okay, now which four of the following are said to be the benefits of life cycle costing? There are total one, two, three, four, five, six. Out of these six bullets, four are the benefits, and you need to drag the benefits down in the table. So in your exam, you need to just drag and drop it here. But now you can only let me know that which options are the benefits. It provides a true financial cost of a product. Yes, this is a benefit. Then second is not a benefit because we cannot shorten the life cycle. The third one, expensive errors are avoided. Yes, this is the benefit. Lower cost can be achieved earlier by design out cost. Yes, we can do it by designing out cost. So the third and fourth is also a benefit. Better selling prices can be set. Declining stage of the life cycle can be avoided. No, we cannot avoid the declining stage. So the second loss is also the benefit. So the benefits are first one, third, fourth, and fifth. So these four items are the benefits. Moving to question number 52. Which of the following statements are true regarding the justification of the use of the life cycle costing? So what are the justifications that why we use the life cycle costing? Product life cycle are becoming increasingly short. Yes, agreed. This means that the initial costs are increasingly important component of the product's overall cost. Yes, we can do it because if we take an example of a cell phone, almost every company is launching a new model every year. So most of the costs are related to the research and development for the new ideas. So the first statement is very comprehensively linked with that. Then product costs are increasingly weighted to the start of the product life cycle and can be properly understand the profitability of a product cost. Those must be matched to the revenue. Yes, agreed, because we need to have the overall profits, not the year wise or the month wise profits. We need to have the overall profit. So the second statement also good. The high cost, for example, research and design, marketing in the early stages in a product life cycle necessitate a high initial. No, this is not the reason of setting the high selling price. The third is not the true. So the fourth one, let me read it. Traditional capital budgeting techniques do not attempt to minimize the cost or the maximize the revenue over the life cycle. Yes, the traditional do not do this. So the life cycle costing do this. So one, two, and four are the true options. No, let me read it again. Traditional capital budgeting techniques do not attempt to minimize the cost. The life cycle also do not minimize it. So uh, overall revenue, minimize the cost or maximize the revenue over the product life cycle. I agreed that the traditional system is not doing that. The traditional budgeting you have studied in management accounting, there was no concept of life cycle in that. But the life cycle does this. So the right answer will be one, two, and four. Only the third option is not correct. So A option is the right answer. Which of the following statements is are true regarding life cycle costing? Okay. Life cycle cost takes into account all the cost incurred in a product life cycle with the exception of sunk cost. No, there is no such an idea that the sunk cost will not be considered. All the costs that will be incurred are taken into account. So the first statement is not true. Life cycle costing ensure a profit is generated over the life of the product. Yes, this is the rule of the life cycle costing, that the profit will be generated overall life of the product. So the second statement is true. Let me read the third one. Life cycle costing is most useful for the products with an even weighting of the cost over their life. No, this is not a condition. So the weightage of the life is not concerned. We have not studied. So the most appropriate answer will be the B option, two only. Question number 54. A company B is about to start the developing of a new product to launch for an existing market. They have forecasted sales of 2000 and marketing department suggests a selling price of 43. The company seeks to make a markup of 40% of the production cost. It is estimated that the lifetime cost of the product will be design and development cost, manufacturing cost, plant dimension cost. Okay. So this is very easy. I guess no hurdle in the calculation. And let me solve it. This is already in total. We just need to multiply 15 with the number of units. This will be 20,000 into 15. How much? 300,000. So 43,000 plus 300,000 plus 30,000. What will be the sum of these three costs? 373,000. Okay. And we will divide it with the number of units. Number of units are given 20,000. So when you will be dividing it with 20,000, how much will be the life cycle cost per unit? Okay, so A option will be the right answer. Very good. Okay, the next topic is related to throughput accounting. And throughput accounting we have not studied so far. So that was the end of target costing and the life cycle costing. Is it clear? Please let me know if there is any confusion. Okay. So the next topic is throughput accounting. This is also a very good topic and not very easy, but it is also not a difficult one. Why I am saying that it is not very easy, because the life cycle costing and the target costing are the very easiest topics of this performance management syllabus. So it is a bit higher level than the life cycle and the target costing topics, but not very hard topic. So I hope that you will also enjoy this topic. Actually, this topic is very interesting. So starting the throughput accounting. Throughput accounting is a product management system which aims to maximize throughput. So basically, we need to manage the product. How we will be managing a product? There might be 2 to 3 products in a situation, and we need to manage that which product is most profitable, which aims to maximize the throughput and therefore cash generation from sales. Remember that in a traditional system, we focus on profit, but in a throughput accounting, we focus on the generation of cash, that how quickly the cash is generated. So the generation of cash from sales rather than the profit. A just-in-time environment is operated, and we also assume that there is no storage of materials. We operate in just-in-time, that we buy the materials as and when needed, with buffer inventory kept only when there is a bottleneck resource. So we cannot have a buffer inventory system. Buffer inventory means spare inventory, and it is allowed only in a situation when there is a bottleneck resource. And what is the meaning of throughput? This is a new idea. So you need to remember that what is the throughput? Throughput is basically sales revenue minus material cost, raw material cost. In this system of accounting, we assume that there is only one variable cost, and that variable cost is a raw material cost. So if we subtract the sales revenue from raw material cost, we will get the throughput. Is it clear? So throughput is a new concept. Throughput is equal to sales revenue minus raw material cost. First of all, we need to have a bottleneck resource. We need to identify a constraint, a binding constraint, or anything which puts a limit on the production. For example, there might be a labor hours shortage, there might be the machine hours shortage. So we need to identify the bottleneck resource, that which process or which resource is a bottleneck. Normally, in a throughput accounting scenario, there might be 2 to 3 production departments, and the product need to go from one department to the other department. So one department will be identified as a bottleneck. Before moving to further, if there is any question, please ask. And if it is clear, then just write in the comment box. Is it clear? Yes or no? Okay. There are 5 steps. The first is identify the constraint. I will apply the 5 steps to the numeric question. The first stage is to identify the constraint. Constraint mean which department is putting a limit. Then decide how to exploit the constraint. Subordinate and synchronize everything. Then evaluate and performance of the constraint. And if the constraint has shifted during any of the above step, go back to step 1. Do not allow inertia to cause a new constraint. So this is all the points will be practically applicable in a production environment, and we will be using the idea of from these steps to apply on a numeric question as well. And what are the assumptions? There should be a bottleneck or a binding constraint which limits the production capacity of the organization. Just in time inventory system. So first assumption is that there must be a bottleneck constraint. Then there is a just-in-time inventory system. Then all production cost as well as the non-production costs are fixed, except raw material. So whole cost associated with the product are assumed to be fixed cost, and the variable one is the raw material cost. Work in progress is valued only at material cost. Profitability is measured at a rate at which the cash sales are generated. That is how quickly goods are produced and to satisfy the customers. It means holding the inventory is not a good thing in throughput accounting, because if we are producing some products, it must be delivered to the customers very quickly. So holding of the inventory is not a good. So there is a comparison difference between conventional and throughput accounting. Please read this difference. And if there will be any confusion, please let me know. I'm waiting. Read it, and after reading, update me. Are these differences between conventional and throughput accounting are clear to you? And if there is any confusion, then let me know. I will explain it. In a traditional system, we assume that inventory is an asset, but in a throughput accounting, inventory is not assumed to be an asset. It is a result of unsynchronized manufacturing and is a barrier to making profit, because we know that if there is a constraint on the production environment, then we must only produce those goods or the units which can be sold quickly. There is no need to pile up the inventory. So having inventory is not a good thing in the throughput accounting. As there is no question or no query from your side, so I assume that the differences between conventional and throughput accounting system are clear to everyone. Now, there is the calculation part. The first thing is throughput accounting ratio. And what is the interpretation of the throughput accounting ratio? Throughput accounting ratio is basically a measure to calculate the profitability, and it is calculated by return per factory hour divided by total fixed cost per factory hour. So basically, there are two things. One is the return per factory hour. We will calculate the return per factory hour, and the return per factory hour is throughput per hour. We can name it as throughput per hour. So the return per factory hour is named as throughput per hour. So first of all, we will calculate the throughput per unit. Then we will divide it with the hours per unit of the bottleneck resource or the bottleneck process. And then we will calculate the fixed cost per hour in the same way. And then we will divide the throughput per hour with the fixed cost per hour. We will get a ratio. And if the ratio is greater than 1, then there is a profit. If the ratio is less than 1, then there is a loss. And if the throughput accounting ratio is equal to 1, then there is a no profit, no loss. That is a break-even point. So first of all, I will solve a question having the requirement of throughput accounting ratio, then you will be able to understand this very well. And we can also improve our throughput accounting ratio. How to improve? These are the points. Improvement means if there is throughput accounting ratio less than 1, then how we can increase the throughput accounting ratio. So let me go to, yes, the first example. Example number 1. A PLC produces 3 products X, Y, and Z. The capacity of A PLC's plant is restricted by process alpha. So here in this question, you can note that the process alpha is a bottleneck. Why? Because it is given that the production capacity of the plant is restricted by process alpha. So process alpha is a bottleneck resource. Process alpha is expected to be operational for 8 hours per day. So this is the per day capacity of process alpha, and can produce 1200 units of X per hour. So this is the production capacity of X units per hour. 1500 units of Y per hour and 600 units of Z per hour. Selling prices and the material cost. So this is the selling price and the material cost. And if we subtract the sale price from the material cost, we will get the throughput ratio, throughput, or we can name it as throughput contribution, but the proper name is throughput per unit. So these are the 3 throughput per unit. The conversion costs are 720,000 per day. And we assume that these costs are fixed cost. Calculate the profit per day if the daily output achieved is 600 units of X, 4,500 units of Y, and 1,200 units of Z. So it is very easy to have the total profit. So X is 600, 6,000, 4,500 for Y, and 1,200 for Z. So we will multiply the throughput per unit with the number of units. So this will be 420,000. What will be the 80 into 4,500? Okay, 200 into 1,200. So what is the total throughput? And what are the conversion cost? 720,000. So the profit per day is 300,000. So in this way, we can calculate the profit per day. So this was very easy requirement. We are given with the data, we just multiplied with the number of units that the question has given in the part A of the requirement, that calculate the profit per day if the daily output achieved. In this question, the output was clearly given, but in some question, output can also be demanded in the requirement, that how many units will be produced. So we will calculate the output as well in the some other question. But here the output was given. We just multiplied the output with the throughput per unit. We have arrived at a total throughput and we have subtracted the total conversion cost. We will get the profit. So this is the part A, and this is very easy one. I guess it is clear. Is it okay to understand the requirement A? And in the requirement B, there is a calculate the throughput TA ratio. Throughput accounting ratio. TA ratio stands for throughput accounting ratio for each product. So we need to have the throughput per hour. And for throughput per hour, we need to have the per unit time. Let me recall you the formula for throughput accounting ratio. The formula for throughput accounting ratio is equal to throughput per hour divided by fixed cost per hour. So we will get the throughput per hour. There are three products, X, Y, and Z, not ABC. It is X, Y, and Z. Throughput per unit is given. Throughput per unit is given 70, 80, and 200. So this is 70, 80, and 200. Throughput per unit is given in the question. We need to have per unit time. It is given in the question that in 1 hour, we produces 1,200 units of X. So 1 over 1,200. The per unit time will be 1 over 1,200 for X. And for Y, 1 over 1,500. Why 1 over 1,500? Because we are producing 1,500 units in 1 hour for Y. And similarly, 600 units of Z. So we are producing 600 units in 1 hour. And when we will divide the 70 with 1 over 1,200, how much will be the throughput per hour? How much will be the throughput per hour? Can you give the answer? First of all, you need to have 1 over 12, the answer of 1 over 12. Then you will divide the 70 over the answer. So I guess this is 84,000. You can just check it from the calculation. Is it 84,000? Okay. So what will be for Y? Throughput per hour. For Y. 120,000. And for Z, I guess this is again 120,000. But you can check it. Now, what is the interpretation? Listen it carefully. As the word is throughput per hour, it means that if I am using 1 hour of a binding constraint, if I am using the 1 hour of a binding constraint, then I will get 84,000 if I go for X. I will get 120,000 per hour if I go for Y and Z. So Y and Z are the most profitable products and X is a lesser profitable. But now throughput per hour. So for X, this is 84,000 throughput per hour. And what are the fixed cost per hour? Let me calculate the fixed cost as well. Fixed costs per hour. The fixed costs are given in the question 720,000 per day. And how many hours in 1 day for process alpha? 8 hours. So what will be the fixed cost per hour? 720,000 was the conversion cost per day, and there are 8 hours of a binding constraint in each day. So what will be the figure of fixed cost per hour? I guess 90,000. Yes. So for X, if you look at the figures of X, the per hour benefit is 84,000 and per hour cost is 90,000. So there is a loss. So what we have studied that if the ratio is less than 1, it will show a loss. And if the ratio is greater than 1, it will show a profit. So what will be the ratio for X? 0.93. So 0.93 is lesser than 1. And for Y, 120 over 90. So what will be the ratio for Y? And this ratio is greater than 1. Why greater than 1? Because benefit is more than the cost per hour. Benefit per hour is more than the cost per hour. And you can look at the answer that the dollar is canceling. So there is no figure, dollar figure with the answer. So this is a ratio. And for Z, $120,000 over $90,000, dollars will be cancelled out. Answer will be 1.30. And this is also showing the profit. Please let me know if there is any confusion that how to calculate throughput accounting ratio. Throughput per hour over fixed cost per hour. Throughput per hour is very simple. Throughput per unit divided by the hours per unit. And which hours you need to take into account? The hours of a binding process. And in this question, the binding process is identified in the question that the process alpha is a binding process. But in the next question, or might be in another question, okay, if there is 1.33, we will write it as 1.33. No need to worry. Whatever the answer is, we will write that answer. Okay, moving to the next question. First of all, before moving to the next question, let me know whether the example 1 is clear to you or not. Okay, so the topic is easy, but a little bit lengthy as compared to the life cycle costing. Okay. In the next question, the first requirement is which process is a binding constraint? And in the second part, what production plan? Production plan mean how many units of one product and how many units of the other product can be produced to maximize the profit. So I will skip this question for today because this question is related to the contribution approach, which is the limiting factor analysis. We will do that question in the next week or probably after that. Then I will do this question because this is a comparison between the limiting factor analysis and throughput accounting. So I will do that question at a later stage. And example 3, let me read the requirement. The first requirement is the identify of the bottleneck process and explain why this process is described as a bottleneck. Okay. Then calculate the throughput accounting ratio. Okay, we will calculate the ratio and then explain how the company can improve the throughput accounting ratio. So there is a theoretical area that how the ratio can be improved. And then there is another theoretical question. Should the C company discontinue to the Christmas cake? And this question is a very good question, very comprehensive example. So this will clear all the ambiguities that the examiner can create in you in the exam question. So focus it. This is a very good past paper question. So let me read it. Clues cake makes 3 different types of cake: birthday, Christmas, and wedding. So there are 3 products: birthday cake, Christmas cake, and wedding cake. Each cake goes through the 3 processes: mixing, baking, and icing. So the first process is mixing, baking, and the third one is the icing. So this is the sequence. Like many businesses, C faces tough competition for a mature market. The cake factory has 20 production lines. 20 production lines mean we can produce cakes at 20 places in one time. So there are 20 production facilities which cover the 3 processes, and in each line there are 3 processes: mixing, baking, and icing. The processing capacity varies for the each process, and the manager has provided the following information. So the processing time per cake in hours, that the birthday cake needs 0.4 for mixing, the birthday cake needs 1 hour for baking, the birthday cake needs 0.8 hours in icing. So there are 3 departments: mixing, baking, and icing, and the 3 products as well. Then if I talk about the Christmas cake needs 0.8 hours in mixing, 1.5 hours in baking, and 1 hour in icing. And similarly, the time for wedding cake in mixing is 1.5. In baking, the time of wedding cake is 1.6. And in icing, the time for wedding cake is 1.5. So in this way, we will read the data. The cake factory is open for 12 hours a day for 6 days per week. The factory closes down for 1 week in summer and 1 week in Christmas. So we will be doing this in the part B. So as far as the part A is concerned, identify the bottleneck process. Now listen carefully. In the example 1, the process alpha was identified as a bottleneck. So in the previous question, the bottleneck was given by the examiner, but now in this question, the bottleneck is missing. We need to identify whether mixing is a bottleneck, whether baking is a bottleneck, or icing is a bottleneck. So we need to identify a bottleneck process. Now, how to identify a bottleneck process? First of all, we need to have the total capacity. Total capacity. of each department. What is the total capacity of each department? It is given. The factory is open for 12 hours a day. Okay. 12 hours in one day, for 6 days in a week, for 50 weeks, because in a year there are 52 weeks, but the factory is closed for 2 weeks, one for summer and one for in winter. And it has 20 production lines. So what is the total annual capacity in hours? Total annual capacity of each department in hours. So what will be the total? 12 into 6 into 50 into 20. Okay, 72,000 hours is the total annual capacity of each department. Okay, so first of all, the first department is mixing. If I talk about the mixing department, and it has a 72,000 hours available. And if I talk about the first product, which is the birthday cake, so 0.4 hours will be required for mixing. 0.4 hours per unit. So how many units I can produce in mixing department for birthday cakes? I will be checking it for birthday cakes. How many units in a year I can produce? So I can produce 180,000 units of birthday cakes in mixing. Then there is a baking department, second step. The capacity will also be the same. But how much time the birthday cake will require for baking? 1 hour. So the number of units that we can produce in baking is 72,000. And then in icing, the capacity will be same, but how many hours one birthday cake will be having in icing? 0.8. So how many units we can produce in icing for birthday cakes? Okay, 90,000. Now, if we look at the answer, the mixing department can mix the raw material for 180,000 units of birthday cakes. Baking department can bake only 72,000 cakes. And icing department can ice 90,000 cakes. It means that the baking department is putting a limit on the production, that it is restricting the production. The wastage, if we mix the raw material for 180,000 cakes, then it will be wasted because the baking can only bake for the 72,000 cakes. That's why we were talking about in the throughput accounting that having the inventory is not an asset. It is a result of unsynchronized process. So inventory will not be here. So no need to mix the extra cakes material. So baking is a binding constraint. So what is the learning outcome? That how we will be identifying a binding constraint. We will calculate the annual production capacity for each product or any of the product. The result will be the same. If we go for the Christmas cake, the result will be the baking department. And if we take the wedding cake, the result will be again the baking department. And the bottleneck process will be a process which puts the limit on the production capacity. So if we talk about the requirement A, Identify the bottleneck process. So this was the whole solution for the part A, that we will calculate the annual production capacity. Then we will take 1 unit of a product. I selected the birthday cakes, and how many birthday cakes can be produced in mixing, how many birthday cakes can be produced in baking, and how many birthday cake can be produced in icing department. And if I talk about the remaining part and explain why this process is described as a bottleneck, and if we need to have an explanation, then we will write as production capacity of baking department is the lowest than mixing and icing. Therefore, baking is a bottleneck process or a bottleneck department or a binding constraint. Is it clear that how you will be identifying the bottleneck process? We will be calculating the annual production capacity of each department. And after that, the department which puts a limit on the annual production requirement will be a bottleneck process. Is it clear? So the first part is clear. Now, in the second part, calculate the throughput accounting ratio. So we have already done throughput accounting ratio. For a throughput accounting ratio, we need to have throughput per hour divided by fixed costs per hour. Now, the question is a bit complex, a lengthy one. So we need to read the question first. The labor rate is 7.5 pounds. Raw material cost is given. Selling price is also given. There is no inventory. So the question is simple. No complexity is actually there. So there are 3 cakes: birthday, Christmas, and wedding cake. So there are 3 cakes. The selling price per unit is given in pounds: 20, 25, and 80. So 20, 25, and 80. Material cost per unit in pounds is also given: 5, 10, and 20. 5, 10, and 20. So if we subtract the material cost from sale price, we will get throughput per unit in pounds. This is 15, this is 60. And after getting the throughput per unit, we need to have hours per unit. Now listen, which hours you need? If we look at the question, there are 3 products, 3 hours for each product. Now, which hours you need to pick? Can anyone answer which hours I will be picking? The hours of mixing, baking, and icing. Can anyone answer? When I will be selecting for the birthday, whether I will be selecting this one, or this one, because I need to divide the throughput per unit with the hours per unit. So which hours I need to select? Yes, baking. Very good. Why? Because our concept is that we will be selecting the hours of a binding constraint or a bottleneck. So the bottleneck in this question is baking department. So for the birthday, we will be taking 1, for Christmas 1.5, and for wedding 1.6, because we will be taking the data of a binding or a bottleneck department. So this is 1 hour, 1.5, and 1.6. So if we divide the throughput per unit with the hours per unit, we will get throughput per hour. So what is the throughput per hour for birthday cake? 15 over 1. So this will be 15 throughput per hour. 15 over 1.5, this will be 10. And what will be 60 over 1.6? 37.5. So these are the throughput per hour for each product. Now we need to have the fixed cost per hour. If we talk about the fixed cost are other factory costs are 200,000 per year. Okay, so fixed cost per hour. The first one is the other cost given in the question. 200,000 annually. And how many hours are on annual basis? 72,000. I guess we have calculated somewhere. Yes, 72,000 hours is the annual capacity. So how many pound is the fixed cost per hour? So 2.78. Okay. And what are the other fixed costs? Labor cost. Why I am taking the labor cost as a fixed cost? Because it in throughput accounting, we assume that the labor is also fixed. Only the variable element is the material cost. So the labor 7.5 is also assumed to be a fixed cost. So 7.5 plus 2.78. What will be the total fixed cost per hour? 10.28, I guess. So this is the fixed cost per hour. And now we will find the throughput accounting ratio for birthday cake. Per birthday, throughput per hour is 15. So 15 divided by 10.28. So the ratio will be how much? 1 point. 1.46. So this is showing the profit. And for a Christmas cake, throughput per hour is 10. And what is the fixed cost per hour? 10.28. So in this case, this is how much? 10 over 10.28. 0.97. Okay. And for wedding cake, throughput per hour is 37.5 and fixed cost are 10.28. So this will be 3 point something. 3.65. So two products are profitable and the most profitable one is the wedding cake and less profitable is birthday cake and Christmas cake is in loss. So the product which is in loss is not financially viable. So in this question, in the requirement B, calculate the throughput accounting ratio of the each product, assuming the bottleneck is fully utilized. So we have already assumed that the bottleneck is fully utilized. Then explain how C should improve the throughput accounting ratio. So here are the points that in which we can improve the throughput accounting ratio. It was given in the handouts that how we can improve the throughput accounting ratio. That if the cost will be reduced, the per unit time will be reduced. There are certain elements. There was the points. Let me show it. These are the points that how we can improve the throughput accounting ratio. So these are the suggested points given in the handouts. So you need to read it by yourself. These are the points that if we do these 5 things, the ratio could be improved. And what is the measure and what is the consequence? If we do this, what will be the result? So you will read it by yourself. And in the D requirement, should the C discontinue to make the Christmas cake? As the throughput accounting ratio of Christmas cake is less than 1, so it is not financially viable because it is generating a loss. So a product which is generating a loss is not good to continue. But as you know that a Christmas is a one-time event in the whole year. So if we are getting a loss in a one product, the customer who will visit us on a Christmas event for a cake, he might visit us for a birthday cake and the wedding cakes during the year. So as the loss is also not a very big loss, there is a minor loss 0.03. It means that there is only a difference in pennies, 0.28 penny per cake, there is a loss. So we can, if we want to consider other factors, then keeping in view the other factors, we can continue it. But based on the throughput accounting ratio principles, it is not financially viable to continue the product. So you can write it that both the things. One, as per throughput accounting ratio, it is not financially viable to continue it. But on the other hand, as the Christmas cake is only at the Christmas Eve and it is only a one-time event and the loss is not also a big loss, so a customer who will try our cake, and if the quality of the cake is very good, the customer might be returning us for the wedding cake and the birthday cake during the year. So we can continue this as well, keeping in view these points. Is it clear? And you can even search it out through the Google. This is a past exam question. You will type this a few of the lines in the Google. You will get the whole solution and the recommendation as well. So this question was being asked about 12 to 15 years back in this exam, and I kept that question in my data bank because this is a very comprehensive question covering the whole scenario, that how to identify a bottleneck resource, how the throughput accounting ratio will be used, and how we can improve it, and how we can decide on the continuous and the discontinuing product based on throughput accounting ratio. Is it clear? There is another past paper question, Baba and Bing. This is also a past paper question having the same requirements. First of all, bottleneck process identification. Then there is a comparison between marginal costing and throughput accounting. So this is a theoretical comparison. I have studied this. Then calculate the optimum production plan. We have not discussed the production plan so far in today's lecture. And then calculate the throughput accounting ratio. So except for the production plan, we have covered the whole topic of throughput accounting ratio. I have missed the throughput accounting production plan because of the comparison between limiting factor and the throughput accounting. So I'm skipping the example, and in this question, you can skip the part C and D, because part C and D is basically the comparison between the limiting factor analysis, which is a contribution approach, and this one. So production plan is skipped for today. The rest of the topic is covered. And the rest of the topic is very simple. Identification of the bottleneck process. And the second thing is calculation of throughput accounting ratio. And this will be done in the next lecture. The production plan related question will be done in the next lecture. Is it clear? Example 5. There are 3 products, product X, Y, and Z. Contribution is given. In this question, the word is throughput. There is a typing mistake. The word is not contribution. Here, this is throughput. 12, 10, and 6. Bottleneck machine hours. This is missing. There is a question mark that which machine is a bottleneck. So there are 3 machines, machine 1, 2, and 3. Sales demand is given. There are 3 machines used for the manufacturing of these products. Details are given below. There are 1600 machine hours for each machine. So there is the total capacity of each machine, product X, Y, and Z. There are 3 products, 3 machines, and we need to select the which machine is a bottleneck. So first of all, we will do in the same way. For example, I am selecting the product X. We can select any product, just like in the previous question, we have selected the birthday cakes. And now I will use the data of product X for machine 1. And what is the machine 1 capacity? The time for each machine is 1600. So 1600 hours is the total capacity. And how many hours product X requires in machine 1? 6. 1600 over 6 hours. How many units of X can be produced by machine 1? Please share the answer. So 266.67 units can be produced in machine 1, and machine 2 has the same capacity. And how many hours product X need in machine 2? 9 hours. So how many units can be produced by machine number 2? So this is 177.78. And for machine 3, capacity is the same, and product X 3 hours. So how much will be the number of units that we can produce from machine 3? 533.33. So which product, which machine is a bottleneck? Machine 2. Why? Because its production capacity is fewer than the other 2 machines. So a department or a machine which puts a limit is a binding constraint. So the hours of the binding constraint, the question marks will be replaced with the time of the machine 2. So we will be using the time of the machine 2, which is 9, 3, and 1.5. So these are the bottleneck machine hours, 9, 3, and 1.5. And we need to have the throughput accounting ratio. So for a throughput accounting ratio, we have simply a formula, throughput per hour divided by fixed cost per hour. So there are three products, X, Y, and Z. Throughput per hour. Throughput per unit is given 12, and if I want to convert it into per hour, I need to divide with the hours, which is 9. So I will get throughput per hour. How much will be the answer? 12 over 9. 12 is the throughput per unit and 9 is the hours. So throughput per hour will be how much? 1.33. Okay. So $1.33 per hour. And what are the fixed cost per hour? Is there any information available regarding fixed cost per hour? The fixed cost per hours are also missing in this question. So there is a typing mistake because in this question, there must be the information available for the fixed cost. So I can assume some fixed cost, no issue. But first of all, let me complete the throughput for Y. The throughput is given $10 divided by the time of machine 2 for Y, which is 3. So what will be the answer of this? 10 over 3. So 3.33. And then we will do the same for Z. Throughput is $6 divided by time of machine to 1.5. So what will be, I guess, 4. So let's say that the fixed costs are given in the question $2 per hour. So this will be $2. I assume that it is given in the question. So there will be less than 1, and this will be 1 point something, and this will be 2. Is it clear? So we can complete the question if we are having the fixed cost per hour and there is a typing mistake in the question. And now, if we want to move to throughput accounting practice questions, we can do it. Do you want to do these questions right now? Do you want to do these questions right now? Can I do it? And if you are feeling tired, then we can plan something else. First of all, let me know if there is any issue or if is it okay to continue. Okay, so let's continue as Ashna is saying that we must continue it. So throughput accounting starts from question number 45. When demand exceeds supply, which one of the following situation would increase the throughput accounting ratio? Can you make a guess that which option is the right answer for question number 55? Please be quick. The first option is related to an increase in the speed of the fastest machine in production process. The machine will not improve the ratio. Okay, D. A 10% sales discount. The discount will affect the throughput. So D is not the right answer. C is the right answer because in C option, there is a 5% increase in the wage linked to 8% productivity. Productivity means there is a reduction in time. If there is a 5% increase in rate, there is a 8% reduction in time. So ultimately, labor cost will be reduced. So C is the answer. If the cost will be reduced, the ratio will be improved. D is not the right answer. Yes, Kushika is saying the right answer. Question number 56. A manufacturing company decides which three mutually exclusive products to make in its factory. Okay, mutually exclusive mean we will only produce one. Sale price, material, machine hours per unit. Total factory cost excluding material are 150. The company cannot make enough of the product to satisfy external demands. What would be the company's throughput accounting ratio? What would be the effect on the throughput accounting ratio on the company's throughput accounting ratio? Please pick the appropriate. Now, first of all, we need to have the original throughput accounting ratio. We need to calculate the throughput accounting ratio for X, Y, and Z. Then we will apply, increase the selling price of Z by 10%. Then what would be the effect on that? If the price will be increased, then what will be the effect on throughput accounting ratio? So if there is an increase, we will take, and if there will be no increase, then we will take it here. So first of all, we need to have the original answer for throughput accounting ratio of X, Y, and Z. And the X, Y, and Z can be calculated. So first of all, what is the throughput? Throughput is the difference between sale price and the material cost. So this is 20, this is 30, this is 4. And if you divide with 20 with 10, we will get throughput 2 per hour. And 30 over 20 will be 1.5 per hour. Do you getting this idea? And 4 over 2.5 will be 1.6. So we will be getting throughput per hour. The fixed cost information is given 150,000 in total. And what is the total capacity of the machine or factory? The total capacity is it given? The total capacity, total cost is given. The total capacity is not given. So if I talk about the condition of the question, which three of the mutually exclusive mean we will go for the one option only. So we will be selecting X, Y, X, because X is generating the highest contribution. So X will be selected. Now, if we increase the sale price of Z by 10%, okay, let's increase the sale price of Z. Then the new price will be 22. It means throughput will be 6. So the 6 will be divided with 2.5. 6 will be divided with 2.5. What will be the answer? What will be the throughput per hour for Z by first condition? 2.4. Okay. It means that if this is 2.4, then most profitable will be Z, not X. So we will take it here. And if we increase the selling price of Y, okay, If we increase the selling price of Y by 10%, so this will be 44. 44 minus 10 will be 34, and 34 will be divided with 20. So this will be how much? This will be less than 2. So we will be taking it here because 2 is the most profitable. Then reduce the material cost of product Z. Okay. By 5%. So if we reduce the material cost of product Z, then this will again be the same situation. No improvement. X will be the most. You can check it. I just make a guess that it will be lesser than 2. And reduce the material cost of Y by 5%. Okay. If we reduce, so this will again be less than 2. So the in this way you will take the answer. Is it clear that how we will be doing this question? First of all, we selected the one which is having the highest throughput per hour, and then we will apply the conditions. And if as a result of that condition, our decision shifts from X to any other product, then we will take, otherwise we would not improve. Then in that case, we will take in the third column. Okay, so moving to question number 57. Sky Limited operates through an environment where the product goes through two processes, process P and Q. There are 8 machines operating at 90%. Each machine produces 6 units per hour. Okay, so there are 8 machines operating at 90% capacity. And each machine produces 6 units per hour. There are 6 machines in process Q operating at 85% capacity. Each machine produces 9 units per hour. Sky Limited produces the cloud, which is not a popular product. The marketing manager has therefore decided to apply a price discount of 15% on the selling price of 20 per unit. So the price will be 20 minus 15% of 20. The material cost is $5. Labor per unit is the twice of the material cost. It currently takes 0.2 hours and 0.3 hours to make a unit of cloud in the machine process P and Q respectively. What is the cloud's throughput per hour for the bottleneck resource? So first of all, we need to identify whether P is a bottleneck and or Q is a bottleneck. So if I talk about the production capacity of P, 8 are the machines, and one machine can produce 6 units per hour. So this will be multiplied with the 6. And they are working at 90% capacity. So how many units the P can produce in 1 hour? Process P can produce how many units? And similarly, 6 into 9 into 85%. So these are the number of units that the Q can produce. Please share the number of units that P and Q can produce in 1 hour. And the department which is producing lesser number is a binding constraint. Please share 43.2 units here and 45.9. So P is a binding constraint because P is producing lesser number of units. Now, throughput accounting, for a throughput accounting, we have a sale price. 20 is the original, but 15% discount will be given. It means the price will be 17. And the direct material cost is given 5. So throughput per unit is 12. And this 12 will be divided with the time of P. So the time of the P is 0.2. So what will be the throughput per hour? The throughput per hour is the requirement. So 12 over 0.2. Why I selected 0.2? Because 0.2 is the time of process P, and process P is a bottleneck. So we will write $60 here. As it is written to the 2 decimal places, so we can write 60.00. Is it clear? Moving to question 58. Units produced, time taken, maximum time available, material purchased, material used, labor cost, overheads, sales. Which of the following is a throughput accounting ratio for this product? So we need to find the throughput accounting ratio. First of all, we will calculate the throughput per hour. And we know that throughput per hour is the throughput per unit divided by hours per unit and divided by fixed cost per hour. But here the hours information is not available. So we can do it with the help of the dollars as well. So if we want to calculate throughput per unit, throughput, then the revenue minus material cost. The revenue is 9,000 sale price minus material cost. The cost of the material is 3,000. So throughput is 6,000. And there is no per unit time, so we cannot convert the throughput per hour. So similarly, we cannot convert the fixed cost per hour, but we can have the total of the fixed cost, which is the labor and the overheads. So what is the total of the fixed cost? It is 3,500. So if we want to calculate throughput accounting ratio, instead of having the per hour figures, we can calculate the total figures. So throughput will be taken in as a total and it will be divided as a fixed cost in total. So we will get again the same answer, which is throughput accounting ratio. So what will be the throughput accounting ratio? 6,000 over 3,500. So 1.71. So C option 1.70 will be selected. Is this question clear? Question number 59. There are 3 processes, process 1 to 3, hours available per day, and there are 2 products, X, Y. I guess you will do it this question by yourself. We have done so many questions, so I'm skipping it for you. You can try it during the week. And if there will be any question, then you can ask me. Question number 60. Which one of the following is not a true of throughput accounting? So you need to select the wrong one. Not true mean false one. Can you make a guess that which statement is false? I am waiting for the answer. When you will be deciding, share your answer. In question number 60, the most appropriate answer is D for Delta. Throughput accounting was designed as a decision-making tool for a situation where there is a bottleneck resource. We have studied in the handouts that this is a product management technique, not a decision-making technique. So the first three options are very much relevant to the concepts of throughput accounting, and D is not a relevant. So this is not true. In question 61, which of the following is a definition of a throughput accounting ratio? This is very easy. Everyone can make a guess that which is the correct formula for throughput accounting ratio. What is the answer for 61? Okay, very good. C. Question number 62. Units produced, units sold, material purchased, opening material, labor cost, overhead cost, sale price. There was no opening inventory of finished goods and closing inventory of materials. Which of the following is the throughput accounting ratio for this product? So we need to find the throughput accounting ratio. For this, we need to have a throughput and the fixed cost. So throughput are the sales less all material cost. Material cost is given in the question, just like in the previous question we did. Now we will be having the revenue. So the revenue will be 35 into 800. How much will be the revenue? 35 into 800. And the material cost is 13,000. So we will be having throughput. 35 into 800 will be how much? 28,000. So 28,000 minus 13,000 will be 15,000 will be the throughput. And what are the costs? The costs are the overheads and the labor. So what are the costs? Total cost are how much? And ours information is not given. So we will do in the same way as we did 2 questions back. So the sum of these will be 11,550. So throughput accounting ratio will be how much? 1.30. So C option will be the right answer. So this was the end of the MCQs for the throughput accounting ratio. The next is related to environmental accounting. We will do this in the next lecture because we have done so many things in today's lecture. The first one was the target costing MCQs. Then we completed the concept of life cycle MCQs. Then we did the questions related to throughput accounting, and we did throughput accounting ratios. And we have done how to identify the bottleneck process, and we have skipped that the production mix, the product mix, because the product mix will be done with another topic, which is dealing with limiting factors. So while I will be doing the dealing with limiting factors, I will be doing these questions as well. So I guess for today's it is enough. What do you say? Do you want to study more, or is it okay? And if you during the week you need to do is complete the reading of target costing, life cycle costing, throughput accounting from your study text, as well as do practice questions in the BPP kit, because I have not done the BPP kit. So during the week, you must spare some time to solve the practice questions from the BPP kit. I have already shared the material with all of you on WhatsApp. The one who have texted me, I shared the material. And if there is some student who is not getting that material, then you can send me a text on WhatsApp. So is it clear for today? Any question from your side? So if there is no question from your side, then we can end the class. Meanwhile, if you will be having any confusion, any ambiguity during the week, you may send me a text so that I can answer you. And if you can give your feedback that how our classes are going on, and if you need any, if you have any suggestion, you can. Otherwise, we can end the class. I guess there is no suggestion. So take care. Bye bye.